All right, today we're doing a deep dive into Blinkit, the absolute giant of India's quick commerce scene. We're going to unpack exactly how they pull off a 10-minute grocery delivery. I mean, we're talking about a massive feat of system design, logistics, and real-time data processing, all happening at a mind-boggling speed and scale.
So, here's the plan. We're going to reverse engineer this whole thing. We'll start with that crazy 10-minute promise they make to customers. Then we'll get into the nitty-gritty, the brutal math behind it, the physical micro-hubs, the digital brain running the show, the human-machine loop that makes it all happen, and finally, how all of this builds one heck of a competitive moat.
Okay, first up, the 10-minute promise. And look, before we even touch the tech, you've got to understand the sheer scale we're talking about here. Blinkit isn't just some fast delivery app. Nope. It's an absolute titan in one of the most competitive markets on the planet.
And here's the proof. Just look at this. Blinkit controls almost half of India's quick commerce market. That's insane. We're talking about a market that was basically invented around the idea of instant gratification. And right now, Blinkit is absolutely dominating the game.
And this is the promise that powers everything. Groceries in under 10 minutes. You have to understand, this isn't some fuzzy marketing slogan. It is a hard, non-negotiable service-level agreement, an SLA. And that single SLA dictates every single decision they make, from the physical layout of their warehouses to the code in their algorithms. Everything is built around this one promise.
Which brings us to the big question. How on earth is that even possible? Let's deconstruct the SLA and look at the actual physics of a 10-minute delivery. We're going to break down the math of cramming a whole delivery process into just 600 seconds. It's unforgiving.
600 seconds. That's it. From the second you hit place order to that doorbell ring, the countdown is on. Every single part of the process has to be, and I mean brutally optimized to fit inside this tiny window. There is zero margin for error. None.
So here's how that 600-second clock gets sliced up. It's merciless. The picker inside the store gets 90 seconds. That's a minute and a half to find everything and bag it. At the exact same time, the system has 90 seconds to process the order and get a rider dispatched. All of that leaves just 420 seconds, 7 minutes, for the rider to actually drive to you. It's a race against the clock in 3 different lanes at once.
And this quote from East India Retail just nails it. This system puts incredible pressure on the people working inside it. They have to pack these orders in just a couple of minutes, trying not to make any mistakes while moving at what is basically machine speed. Every single second they can save matters.
Okay, let's talk about the physical layer, the micro hub. This is the hardware of the operation. And the secret really starts inside a place you've probably driven past 100 times but never noticed, something called a dark store. Now, what is a dark store? It's not a shop. You can't walk in. It's a small, super efficient warehouse, basically a micro-fulfillment center. And here's the key. They are strategically plunked right in the middle of dense neighborhoods. The whole point is to shrink that last-mile delivery distance down to almost nothing.
And this is where you really see the paradigm shift. The old way? A giant warehouse outside the city, fulfilling orders that take hours or days. The Blinkit way? Hundreds of these small dark stores right within a couple of kilometers of you, fulfilling orders in minutes. It's a total flip from a centralized, slow model to a decentralized, insanely fast one.
So how do you pick an order in 90 seconds? Well, the dark store's layout is literally an algorithm brought to life. Nothing is random. The most popular items, what they call high-velocity SKUs, are put in the easiest-to-reach spots. Pickers get directions on handhelds telling them the absolute fastest route. And because there are no customers wandering around, the aisles can be super narrow and optimized for pure speed. You basically engineer out all the wasted time.
All right, we've seen the hardware. Now let's look at the software that runs it all, the digital brain. This is the central nervous system, the orchestration layer that has to keep every order, every picker, and every rider moving in perfect sync, all in real time. So let's pop the hood and look at the tech stack. No surprises here, it's a modern microservices setup built for massive scale. You've got things like Kafka and RabbitMQ, which are absolutely essential for handling the fire hose of real-time events. Orders coming in, riders moving around. Then there's Redis for super fast in-memory caching, so inventory checks are instant. The whole thing runs on Kubernetes and Docker, because in this game, downtime just isn't an option. High availability is everything.
Okay, let's trace an order through this system. The moment you tap that button, a whole automated sequence fires off. An inventory check hits Redis and comes back in milliseconds. A picker's device lights up with the order, and this is the really critical part. The AI writer dispatch starts at the same time. It's a parallel process. So by the time the picker has your stuff in a bag, the system has already found the closest writer and assigned them the delivery. There's no waiting.
But look, awesome tech is only half the battle. Now we have to talk about the human-machine loop. Let's dig into the sheer operational density. I mean, the raw number of people it takes to make this machine work, especially when things get busy.
And the numbers are, well, they're staggering. For a single dark store pushing out about 2,000 orders a day, you need maybe a dozen pickers inside. Okay, but look at the riders. To keep that 10-minute promise, you need somewhere between 33 and 65 riders per hour. That's an enormous fleet just buzzing around one tiny warehouse.
So that begs a huge question, right? How do you manage that many people efficiently? You've got dozens, sometimes hundreds of people, all moving at top speed. How do you possibly get that human network to operate with the cold, hard precision of a machine?
Well, the answer is to create a really tight feedback loop between the people and the technology. You start by flooding the zone with riders, just ensuring there's always someone nearby. You use tech to guide the pickers, taking the guesswork out of their job and minimizing their cognitive load. And then the AI uses things like real-time heat maps to see where every rider is so it can make smart dispatch choices and even batch orders together when it makes sense.
Okay, let's zoom all the way out. We've talked stores, we've talked tech, we've talked people. What does all this add up to? Well, it adds up to building the density moat, a powerful, really hard to replicate competitive advantage.
So what's a density moat? It's an entry barrier that's built from a capital-intensive physical network, all those dark stores, and extreme logistical density, meaning all those riders. This is not some app you can code in your garage over a weekend. To compete with this, you need a mountain of cash and some serious operational chops. It makes it incredibly difficult for anyone new to even get a foothold. And here's what that moat looks like in the real world. Over 2,000 dark stores. That's the scale we're talking about. A sprawling, interconnected web of these little micro-hubs. And every single one of them is engineered for one thing and one thing only: insane speed.
So Blinkit has built this incredible moat. What we've really seen today is the ultimate case study of system design principles being applied under the most extreme pressure imaginable. The big takeaway? Every layer, the physical stores, the digital brain, the human network, is all obsessively optimized around that one single non-negotiable SLA. So, in our final episode, we're going to ask, how do you build this stack for your own operation? See you then.